Okay, so I mentioned in a previous video that functions were actually relations, and we defined a relation to just be a subset of the Cartesian product A cross B for any sets A and B. So we can also define a function as a relation. So a function f from A to B, for domain A to codomain B, can also be defined as a subset of A cross B and hence a relation. So in particular, it would be a subset of A cross B. It would be a collection of ordered pairs, one from an element of A and one from an element of B, so that each element of A occurs in exactly one pair and is assigned to exactly one element in B. So that is the definition of a function in terms of a relation. So in particular, we could define a relation in set notation like this. So it's a set of ordered pairs A, B, where A is an element of A and f of A is equal to B. So B is actually the image of A under the function f. And moreover, we have the condition that the function from A to B contains one and only one ordered pair A, B for every element A and A. So let's look at an example. So recall from the previous video, we looked at an example of the Cartesian product of A and B, where A was the set of small letters A and B was the set of numbers 1, 2, 3. So the Cartesian product of A and B was formed by taking each element of A and pairing it with each element of B. So in order to consider a function from A to B, we need to, remember, pair each element of A with exactly one element from B. So the following set A1, B2 would define a function because each element of A occurs exactly once in an ordered pair and is assigned to exactly one element in B. Right? So this means that our function f defined in this way would assign A to 1 and B to 2, and this would be a function. However, these other sets down here are subsets of A cross B, or the Cartesian product of A and B, and they are relations, and so they are relations, but they are not functions. So this first set is not a function. Why? Well, because the element B in A does not appear in any ordered pair in this set. So this relation only maps A to 1, but it doesn't tell us where to map B. So that means that this relation is not a function. On the other hand, this set here is also not a function. It does include an ordered pair which contains the element B, so it does contain ordered pairs for each element in A, but unfortunately it has two ordered pairs with the element B in it. So this means that this relation assigns B to 1 and B to 3, or relates B to 1 and B to 3, but that's not allowed in a function because the function can only assign exactly one element of B to each element in A. So because B appears twice in this subset of the Cartesian product of A and B, then this does not define a function.